As you said, my name is Nathan Handler, and I'm talking about PaaSTA, our platform as a service tool that we built at Yelp. So a little about me. I'm at Nathan Handler on Twitter or nhandler on most other services. I'm a site reliability engineer at Yelp. In my spare time, I'm an Ubuntu and Debian developer, as well as a staff member on the Freenode IRC network, and I'm also one of the PaaSTA developers. So Yelp's mission is to connect people with great local businesses. In the past quarter, we had about 90 million unique monthly views. We've had about 102 million reviews written since our inception, about 70% of total searches taking place on mobile, and we're in 32 countries. So with that out of the way, a little history about how Yelp used to do their deployments and how we used to run the site. So historically, the Yelp application was a giant monolithic Python application with approximately 3 million lines of code. Because of its huge size, things like builds and deployments really took a long time. And since they took so long, we were only able to do a couple of deployments each day. This made mistakes very painful. They were usually very large impacting and would affect many different aspects of the site. They were very difficult to find due to the large code base, and they were slow to fix, both because it took time to locate and prepare a patch, as well as the fact that doing another deploy to fix the bug was just slow. To try and fix this, we started to move towards a service-oriented architecture. So in our first attempt, we started by splitting out the different features into their own applications, similar to what many of you might have done if you made the switch from a monolith. The smaller services that we prepared made it a lot faster to push. We could push services individually of one another and on their own timetables. We didn't need to wait until all of the service authors were ready. They also made things easier to reason about when we had problems. Usually a problem will occur relatively close to a code deployment, so we were able to instantly narrow it down to the right code base and start preparing a patch. And finally, and probably most importantly, it allowed us to start scaling services. With the monolith, because of its huge size, it was very difficult to scale it and very costly. With the services, each service author could specify the number of instances that they wanted, how many boxes they needed, and we could run multiple copies of individual services without necessarily needing to scale up every other service at the same rate. So I've been throwing around the term service quite a bit, so it's probably worth clarifying what I actually mean by that. So a service at Yelp is typically a standalone application. It's stateless, which allows us to quickly deploy it to different boxes and not have to worry about transferring the giant data with it for the most part. We tend to isolate them into their own Git repositories, which makes development fast and easy. You don't need to download a giant 100+ gigabyte code repository just to start contributing. At Yelp, most of our services have an HTTP API, which we use for communicating between them. And they're powered usually by Python applications using Pyramid and UWSGI, and then a virtual env for handling the Python libraries that they need. For deployments with this new service-oriented architecture, we changed things up a bit. Since I mentioned that we could scale services individually, we needed a way to specify how many instances we needed and where each service should run. So for this first attempt, we went for statically defined lists of hosts. These were just regular plain text files saying that service A should be running on boxes 1, 2, and 3. Service B should be on boxes 4, 5, and 6. Our operations team was responsible for maintaining these lists, mainly because our operations team handles capacity planning, and it made sense to keep them in the loop, and they would have the best understanding of where we had available resources. It was all very manual. Likewise, monitoring for these services had to be done through Nagios, and it was also done manually. We had to manually tell Nagios where the service was running, how it should be checked, and it was just rather slow and tedious. For the deployments themselves, we used rsync. which was eventually consistent there and worked out. So this first service-oriented architecture approach and the way we handled deployments, it worked pretty well. It was a lot better than the monolith that we had before, and we stuck with it for a while. But eventually, we started to grow, and we realized this just isn't going to scale. Trying to have an operations team manually tracking the capacity of our entire cluster and maintaining lists of where service should run, or manually updating Nagios to add new checks, we just didn't have the manpower to be able to keep up with that. You also run into issues with this approach of what happens when a service is suddenly running on all of your available boxes. We had nowhere else to go, and the only option at that point is buy new boxes, and it's just an expensive approach. This led us to a new solution. We decided to start developing what we call PaaSTA. So PaaSTA is Yelp's platform as a service. It's responsible for handling the builds, deployments, connecting to the service, as well as monitoring of the service. Rather than building it all from scratch, we built it on top of established open source projects. PaaSTA itself serves as a sort of glue between the various components. This allowed us to get started pretty quickly, gives us a lot of stability and trust that everything's just going to continue to work. We decided to open source PaaSTA this past fall, so it's available on GitHub under an Apache license, so you're more than welcome to go, check it out, and view it. So I mentioned that PaaSTA is built on top of a ton of open source tools. Here's a rough diagram of what a typical service deployment might look like. So you can see popular tools like Jenkins, we have Git in there, Docker, Marathon, Sensu. I know the diagram might be a bit overwhelming here, so we're going to break it up into smaller chunks and go into a bit more detail about what's actually involved here. So the first step in our pipeline is the developer needs to push a change to Git. We use Git for all of our services at Yelp. It just works out pretty well for us. So here's what a typical minimal service might look like. It's just a few files. You have a Docker file. You have some index.php file and a status page, so a simple PHP website in there. You also have a make file. So the make file is just your standard make file. It's not a build pack. It's nothing really special to PaaSTA. This means you can use whatever existing workflows you have for editing and testing and building up your make files. It also gave our developers a lot of familiarity, so we weren't tossing a completely foreign system and workflow at them. About the only thing that's really special about this make file is this iTest target in here. The iTest target is ultimately responsible for producing a Docker container as well as running any integration tests that you might have for your service. We'll see it a bit more in a few more slides here. For Docker, it's just your typical Docker containers there, nothing really special. For anyone not familiar with it, you can think of containers sort of like lightweight VMs. They give you a language called a Docker file where you can describe sort of a recipe for building up what the container should look like, the operating system, the packages you need, the libraries, any files. It makes things very reproducible. If you have the Docker file, for the most part, you can rebuild it and have a very similar setup, if not identical. And then it gives us a lot of flexibility. So with the monolith, if you want to upgrade to a new version of a library, you need to get the entire code base to reliably support it. And once you're at our scale, that's a very difficult process. With Docker, we can upgrade individual services to new versions of libraries, new languages. So I mentioned that this demo app is using PHP, but other stuff at Yelp uses Python or Java. You can also upgrade the entire operating system to a new version of Ubuntu, Debian, or whatever other operating system you might want to run. So the Docker file for this simple service is pretty straightforward. We're using Ubuntu Xenial, the latest LTS release that just came out. We tell it to install Apache and add PHP support for it. Specify a couple of environment variables that Apache needs to run. We remove the default web page and copy over the index.php file and that status file that we saw earlier. And then we just run Apache in the foreground on port 8888. That's part of our PaaSTA contract for service authors. They have to have their services listening on that port. One tool that we give to our service authors to help make their lives a bit easier is a tool called PaaSTA Check. PaaSTA Check allows them to quickly see, do they have any issues with their service? They can run it locally, which means they don't need to do a push and wait for the whole pipeline to complete before noticing that they have an error that just takes a second to fix. You can think of it sort of like a linter for the services. In this example, you can see from the green check marks that for the most part, it's pretty good. And however, near the top, you can see a couple of red X's. That's notifying me that I have some issues that I might want to address. In this case, it's complaining about no security check or performance check present, which are safe to ignore for this simple app. But for a production quality application, we'd encourage the authors to get all of these items green before deploying. So at this point, the service author has pushed their code to Git, and the next step involves Jenkins. So Jenkins will automatically detect that something has changed in their repository, and it'll pull down the changes. It'll run the service through a pipeline that we have, and then ultimately it'll push some changes back to Git, as well as push the final image to our Docker registry. So I mentioned a pipeline. This is all configured in a file called deploy.yaml, which is a standard YAML file. This file is used to specify the different steps in the pipeline. So you can see that I have 3 different steps: an iTest, a push to registry, and dev.everything. You can add additional steps if needed. For a simple service, this is sufficient. Those steps will get converted by a PaaSTA tool into a Jenkins pipeline. So this is an example. You can see about 5 different builds that have taken place over time. So a little tough to read there. The first column there is called services.devops. That one will detect that I've made a change to my service in Git. It'll run make test, which gives service authors the ability to run some unit tests. That would be defined in that same make file we saw earlier. Assuming those unit tests, if any, pass, it'll run PaaSTA iTest, which basically just calls make iTest. This goes back to that iTest target we saw in the make file before, which, as I mentioned, is responsible for producing a Docker image as well as running any integration tests that you might have. Assuming all of those tests pass and that we were able to produce a Docker image, the push to registry step in the pipeline is next. This step will push up the Docker image to the registry that we saw in that flow chart. And then finally, we have the deploy to dev.everything step. Here, we'll run a script called mark for deployment, which simply makes a tag in the Git repository. This tag will get processed by additional tools later on, but it instructs us to deploy this service to the dev.everything deploy group. So I mentioned that the last step in the pipeline involves running mark for deployment to add some Git tags. We use Git as the control plane for PaaSTA, and the tags are how we specify different aspects about it. So you can see we have a specific format for the tags. We prefix them all with PaaSTA. We specify that it should be deployed to the nova-devc cluster. You can have multiple clusters with PaaSTA, and it'll handle them similarly. Demo refers to the instance name, which we'll see more of later. We have a timestamp in here, which is used for figuring out which of these tags is the most recent and should actually be looked at. And then finally, we have a state attribute. So we have the deploy state, which is what mark for deployment will actually mark, noting that we did a deployment at this specified time. You have the stop tag, which can be used to stop a service that's running. And then you have start, which can be used to start it back up again. We use a declarative control for PaaSTA. By this, I mean you describe the end goal, not the path to actually reach it. This is useful for things like fault tolerance. So rather than saying deploy this particular Git SHA to production, you would tell PaaSTA that this commit should be running in production. You can think of it sort of like a gas pedal versus cruise control. So with cruise control, you tell your car, I want to be driving at this particular speed. You don't necessarily care if you have to speed up or slow down to get there, and you don't care what your car does under the hood. You just trust that it'll get you there. This is a bit different than things like a Docker file that we saw earlier, where we told it step by step how to build up the container that we wanted. We have a PaaSTA info command, which we typically point people interested in a service that might not necessarily be their own to. This reveals a lot of metadata about the service, so you can get a description of what it does, an external link containing some additional information. Monitored by will tell you who's getting alerted about issues for this service, and it'll usually allow you to find a team that's ultimately responsible. We have a concept of runbooks at Yelp, which are these documents that tell you how to deal with different issues and different workflows for working with the service. You have the Git repository, a link to the Jenkins pipeline that we saw earlier. It's telling me that the service is deployed to the Nova Dev C cluster. It has a smart stack endpoint that I'll talk about more later. And then it has a link to the monitoring dashboard that I'll also show off a bit later. So now Jenkins has pushed up some tags to our Git repository. It's uploaded the Docker container that we need to our registry. The next step involves something called Marathon. So we use Mesos and Marathon internally underneath the hood in PaaSTA. You can think of Mesos sort of like an SDK for distributed systems. The batteries are not included with Mesos, which means that you need a framework. We use two frameworks with Mesos at Yelp. We use Marathon, which I've mentioned before. Marathon is used for running long-running services. We then have Chronos, which we use for scheduled batches, sort of like a distributed cron in a sense. Mesos is capable of running many different frameworks on the same cluster. And then it also supports Docker, which is really useful, as we saw earlier, for just running different operating systems, libraries. It also allows us to run multiple copies of the same service on the same physical box, which helps for scaling. We control Marathon through another YAML file. Demo here is an instance name. You can have multiple instances, which can be useful for having maybe a canary instance or specifying different attributes for your staging instance than your production one. We specify the number of CPUs our service needs. This one's fairly lightweight. We tell it that we want 3 instances running, or 3 different copies of the service. We tell it how much memory we need. You can specify some monitoring information. So we want it to notify us immediately. You can specify a bounce method. I'll explain this in a bit more later, but basically the bounce method controls how we go from one version of a service to the next. And then a deploy group. The deploy groups simplify our pipelines in Jenkins quite a bit. So it allows you to do things such as specifying all of your production instances should get deployed together, or you want your staging instances to get deployed before production, or maybe you want to specify that your canary instance should get deployed before you do all of your production ones. It just gives you some more flexibility without having to specify everything individually in your pipelines. So that's Marathon. Now, we probably want to figure out how do the services actually get deployed and start running on the physical boxes. To do this, we need to actually do a bounce. So as I mentioned, a bounce is how we go from one version of a service to the next. In PaaSTA, we give a number of different bounce strategies that our service authors can pick and choose between. In this case, I'm using a brutal bounce. You probably wouldn't ever want to use this for a real service. It stops the old version, starts the new one. It doesn't care at all about its health or safety. You'll likely be down for part of it, but it's fast. We have something called up then down, which will bring up the new version of the service, wait until it's all healthy, and then it'll start stopping the old version. This can be useful if your service needs a quorum, for instance, and you need to have 3 or 5 instances all running and healthy before you start tearing down the old one. We also have something called down then up, which is sort of the opposite. This one will stop all instances of the old version, wait for them to die, and then it'll start the new version. This can be useful if you are trying to make like a schema change, for instance, and you don't want any versions or any of the old instances running with the old schema when you're trying to deploy the new one. And then finally, we have the crossover bounce. This is our default one and probably the safest. It's a nice compromise between speed as well as safety. For this one, we'll start the new version of the service, and as instances come up and are healthy, we'll gradually kill off the old ones. So you have the potential to have up to 2 times the number of instances running, but it'll be a fairly safe bounce. This is one of the things that really separates PaaSTA from other tools out there. Most of them don't give you this sort of flexibility and control, and it's something that our service authors really appreciate. So at this point, we've done a bounce and we have our service running. We can go to it in our web browser and we'll see this simple PHP info. Nothing too special here. You can see in the address bar, we specified the demo instance name. DevOps was the name of our service. Nova Dev C was the cluster. Nowhere in here am I telling it, I want to access this service on a particular host. I don't even necessarily know what host it's running on. PaaSTA will just automatically load balance and find where to load the service from. In this case, it's loading it from serve1 US East 1 bdev C. It's also loading it from a Docker container there. If I were to reload the page, we're now loading it from a different host, serve1 US East 1 adev C. All this was done automatically for me. I didn't need to do anything to get this load balancing. PaaSTA just handled it. And this will scale up to however many instances you want. So if I were to keep refreshing, eventually I would get that 3rd instance. It's also worth just reiterating. We saw earlier that this was showing the PHP info page, but most of our services at Yelp are Python apps. PaaSTA doesn't care. It's using Docker under the hood. So the same process would work just the same if it was a Python app or Java or any other language you pick and choose. So I mentioned earlier that the PaaSTA info command was showing us a smart stack URL, and I also mentioned the load balancing. This is all done through Smart Stack, which Airbnb released. So in this diagram, you have 2 boxes. Box 1 is running a PaaSTA service. Box 2 is a client trying to connect to the service. And the way this is handled is, on box 1, we have a script that'll query the Mesos slave to determine the services that are running there. It'll then, NERT will use this information to register the service in Zookeeper, assuming that the health checks for the service pass. On box 2, we have a tool called Synapse, which will query Zookeeper and automatically generate HA proxy configurations. The client running on this box can then connect via HA proxy to the service. This is all done automatically. The service author doesn't need to have any understanding of what Nerve, Synapse, Zookeeper, or SmartStack are, and they still get to take advantage of this load balancing. Another reason that we chose to use SmartStack is that it allowed us to easily migrate from our classic service-oriented architecture with the handcrafted configuration files that I mentioned earlier to PaaSTA. The classic services would just register right alongside the PaaSTA instances, and our end users wouldn't be any wiser. So we also have a concept of latency zones. These give us a bit of flexibility but need some explanation. So a habitat you can think of as sort of a cage in a data center, or in AWS, you might think of it as an availability zone. A region might be an entire physical data center or an AWS region. And then a super region is made up of multiple regions in the same rough geographic area. So the super region might have AWS regions as well as physical data centers combined in it. This gives us a lot of flexibility to control the trade-off between latency as well as availability. So if you deploy your service at the super region level and one of our data centers is having trouble, PaaSTA will reshuffle the instances and get you running on AWS, and you should be fine. Whereas if you go the opposite route and prefer low latency, you might deploy your service within the same habitat. In that case, the latency between the instances will be very low, but if we lose that habitat, you might be down. The way we specify all of this is through another YAML file. You're probably seeing a trend here. In this smartstack.yaml file, you specify the nerve namespace, which is demo. In this case, I'm advertising and discovering at the region level, so rough trade-off, sort of taking the middle route there between availability and latency. And then I specify a proxy port. This is unique for my service, and it's how you connect to it from outside here. You have a PaaSTA status command that service authors can use. So PaaSTA status allows our service authors to view a lot of information about their service. So they can see the Git SHA that's currently being deployed. They can also see the current state. So in this case, it's running. It's healthy in marathon with all 3 out of 3 instances that I wanted running. It's healthy in ASOS. And then SmartStack is reporting it as healthy as well. There's also a link to the Jenkins pipeline once again to easily see the status of the last deployment. There's also a PaaSTA metastatus command. This is useful for our operations team. Occasionally, we'll run out of capacity in a cluster. So this allows us to quickly see if that's the case or if our services are just having issues. It shows things such as the dashboards for Marathon, SmartStack, Kronos, and Mesos. Those are just the standard dashboards that all of those services provide. It shows us the amount of CPU, memory, and disk space that are being used or are available within the cluster. And it shows the general health of things like Marathon and Kronos. So we have our service running, but nothing's really complete until it's monitored. For the monitoring, we're going to use a tool called Sensu. So Sensu was a change from Nagios for us. We like it because it doesn't require us to specify in advance where a service is running or how to check it. You can ship the checks with the code that actually needs it. With that said, we do give some free monitoring to all of our services just by default. We have a monitoring.yaml file, so another configuration file that our service authors can use and tweak. For this service, it's paging an nhandler team and as well as sending an email. You can set this up however you want. You also get the flexibility to specify things like maybe you only want to get paged for problems in production and not for anything in your staging cluster. Or maybe you don't actually want it to page, but you want it to notify you on IRC. Sensu is what allows us to do all of this. So one example of a check that we give all of our services by default is a replication check. So this will alert them if they want 20 instances of their service running and they only have 5, there's likely an issue, and we'll notify them. So this is a screenshot of the dashboard. It reveals things like the run book that they were able to specify earlier, as well as a tip for how to potentially deal with this issue. Gives them the history and just some other metadata that might be useful. So at this point, we're basically completed the story here. The developer has made a change to their service. They pushed it to Git. Jenkins detected that change, pulled it down, ran through a pipeline. It pushed the tags back to Git. It uploaded the image to our Docker registry. Marathon, through the Marathon YAML file, started spinning up some instances on our boxes. And then Sensu is monitoring the service. One of the new features that we've recently worked on is auto-scaling. So in these graphs, the top one is showing CPU usage. The bottom graph is showing the number of instances running. You can see as the CPU usage rises, the number of instances also rises. And then when the CPU usage fell again, the number of instances gradually got dropped. This is being implemented through a PID controller, and it's very easy for our service authors to opt into. In the configuration file we saw earlier where I specified I want 3 instances running, all you do is change that, and instead of specifying the number of instances, you specify the minimum number and the maximum number of instances. There are also some additional tweaks if you want to adjust the metric that is being used to control the scaling. There are also ways to take full control if you want to handle it all yourself. The next step that we're currently working on, it's not quite complete, but we hope to have it done soon, is actually auto-scaling the cluster. So I mentioned earlier that occasionally we'll max out our CPU usage or our memory usage in a cluster. Maybe we'll run out of disk space. Rather than permanently increasing the size of our clusters and wasting that additional money, this would allow us to spin up new boxes as we need them and then gradually get rid of them when they're no longer needed. So a service like Yelp, maybe around the holidays or some other peak times, we scale up the cluster, and then during non-peak times when people are sleeping and whatnot, we can scale it back down and save some money. So that's the end of my slides here. I can take some questions. I can also do a bit of a live demo here just to show how this might look. So does anyone have any questions? Yeah.
What information is pushed and how is it used?
So the question was if I could elaborate about what information Jenkins is actually pushing back to Git and how it's used. So Jenkins is running a tool called PaaSTA mark for deployment. Under the hood, all this is doing is making a Git tag in the repository, similar to the ones that I had earlier there. Sorry, 1 second. So it's making a Git tag similar to one of these here. We then have a script that's running. It'll go through all the tags on the repository, look at the timestamp, and determine which of these tags was made the most recent. It'll ignore all the older ones. It'll then spit out a JSON file saying that the demo instance of our DevOps service here should be in a state of start, or it should be stopped. And it'll contain the necessary information for PaaSTA to find the Docker container that corresponds to this Git SHA. So it's nothing too complicated there. It's using very standard tools. Since it is just a Git tag under the hood, it also makes it very easy to manually control it. So if a service author doesn't want to go through our Jenkins pipeline for some reason and has their own procedure, there are manual steps that they can take to inform all the PaaSTA tools. Any other questions?
apt-get is being performed when the Docker image is being generated? Is it apt-get from outside, from an external auditor? And if yes, aren't you concerned about getting very new and maybe not stable version?
The question was, in the Docker file, it was using apt-get to install some packages. Are we downloading those from an external repository? And if so, are we concerned about getting some very new versions of packages that might be unstable or whatnot? So at the heart of the matter, PaaSTA doesn't really care. It's a Docker file. So in the case of this service here, if I just back up a bit, we're using the Ubuntu Xenial image as our base. So that'll have your standard Ubuntu source.list repositories. So this example would be downloading from the regular Ubuntu repositories, whatever version of Apache is in them. If a service author cares a bit more, we do have some internal apt repositories that we run at Yelp, and we do have some safeguards in there to avoid having new or unstable versions, and they can use those. But this gives the service author complete control. If they want the bleeding edge and they have checks in place. It's also worth noting that this is still a pretty manual deploy there. It's not just going to rebuild the Docker image and push it out without them. They need the service author has control over when their deploys are going to take place. So even if they're using the Ubuntu Xenial repositories, they don't necessarily need to push a new version all the time, and they can wait until they've tested it a bit internally. Any other questions? All right. I guess I'll show a brief demo here. So I'm just going to go into our DevOps service over here. And just so you can see, it's the same service that we had before. I'm going to make a quick little change here. We'll just update our index.php file here. So at this point, I'm just going to commit it and hope that this live demo actually cooperates. That's not what I wanted. So at this point, here's the Jenkins pipeline that we saw before. I'm just going to kick build off here. You can see that it's going through the process. It's just your standard Jenkins pipeline plugin here. So here it's downloading the code from Git. We have our DevOps iTest target here, which I mentioned before is responsible for producing the Docker container and running any integration tests. So you can see it's going through the Docker build process that's taking place. Just building up the container. And it was a success, and it's kicking off the push to registry step in the pipeline. It's a little slow here. The internet's not quite as fast. So here it's pushing up the Docker image to our registry. And let's just refresh here. There we go. And then the last step is the deploy step. This step here is responsible for running the mark for deployment and doing the get tag that you asked about earlier. So if I pull this up in here, it's a rather short step, but you can see down there it's, let's see if I can do this. It's just calling PaaSTA mark for deployment, passing in the get URL, the get commit that we actually just made, the dev.everythingdeploy group, and the service name, and then it's marking it for deployment. So nothing too fancy under the hood. So at this point, our service, the new version of the service is there. So let's run PaaSTA status. We'll add some verbosity there for some more information. You can see down below here, the last change was a minute ago. Status showing up 1 out of 2 there. So it's still going through the deployment there. You can see Marathon's reporting it as critical. That's mainly due to the brutal bounce that I'm using here for speed. If I run this again, it should finish up shortly here. So you can see it's still in a bouncing state with the brutal bounce, but it's getting there. So we'll give that a minute there. If I was worried that I didn't necessarily have capacity for this cluster, I could run metastatus, just specify the cluster. And it's telling me that everything's okay there, so probably nothing to really worry about in terms of capacity. It's just taking a minute to scale. So if I flip back over and I load up the URL over here, you can see that live demos are fun is now appearing. I can zoom in a bit there for people in the back. And if I just refresh a couple of times here, you can see that physical host name as well as the Docker host name changing. So that's pretty much what PaaSTA does there. Are there any questions about any of this? All right. Thank you.